Understanding the effects of microgravity on the human body is essential to enabling astronauts to travel through the harsh environment of space for months or even years. Significant changes to the body's skeletal and muscle systems have been studied for decades, and strategies to maintain physical fitness are being applied through various countermeasures, including vigorous exercise aboard the International Space Station. But scientists and researchers still have a lot to learn, including how time spent in space affects the eyes and brain. Even during a trip as short as 2 weeks, vision changes occur for about a third of American astronauts. When the trip is longer, say 4 to 6 months, that figure may double. But before potential solutions can be proposed, scientists first have to understand what's causing these changes. On Earth, gravity forces a body's natural blood volume downward, below the waist. Our heart forces it back up to the areas above the waist, including our eyes. But what happens to that volume of blood and other fluids when gravity is no longer pulling them down? The human body has an amazing ability to adapt. Sensors in the upper body note when too much fluid is being received, so the body will decrease its overall blood volume in microgravity. However, this response doesn't always completely counter these fluid shifts. This can sometimes be seen in pictures or videos of astronauts aboard the space station. If their faces look puffy, it can indicate there's too much fluid in their head. Does this fluid also accumulate in or around the eyes? Vision researchers are working to better understand whether the chronic fluids shift toward the head during spaceflight are causing the shape of the eye to change, or if fluid is accumulating at the back of the eye. An imaging technique called optical coherence tomography uses a special camera to take pictures of the back of the eye and helps scientists to better understand the effects of increased fluid accumulation found in the tissue there. Dr. Stephen Laurie is the lead scientist for spaceflight-associated neuroocular syndrome research. He says, "We have known since astronauts flew short-duration space shuttle missions that vision changes during spaceflight occur faster than would be expected during the same time period on Earth. However, once we started seeing swelling at the back of the eye surrounding the optic nerve, this became more concerning, because it has the potential to lead to long-term changes in vision that cannot be fixed with new prescription lenses." Another challenge for scientists is that astronauts may not conform to a one-size-fits-all treatment approach. While all astronauts experience chronic weightlessness, about 70% show the earliest signs of fluid accumulating at the back of the eye, and only 15% show more concerning signs of this. When they return to Earth's gravity, these changes can take up to a year to resolve, with some changes to the eye never fully returning to how they were before spaceflight. Both men and women have been affected in either or both eyes. Dr. Laurie concludes, researchers and medical doctors closely monitor astronauts during and after spaceflight to determine if any permanent vision changes will emerge, while also continuing with research to learn more about the underlying causes of these changes. For more information about how astronauts maintain their health on board the space station, go to www.nasa.gov/ISS-science. To discover more about the space on, around, and beyond our planet, visit science.nasa.gov.